Welcome back, fetchers. I want you to do these 4 problems, okay? So in a minute, when I tell you to stop, I want you to just pause and spend a few minutes doing these top 2 problems. And then these 2 at the bottom are nasty looking. And I'm just going to tell you straight up, you don't have ones like this on the test, but you do have some like this in the homework. And as soon as we start bringing in fractions and decimals, you get a little panicked. I'll give you a hint before you do this. Focus on the denominator here. You can see that's a common denominator, and you can factor that out. And focus on, what if you didn't have decimals here, okay? What if this was 24 and 8 and 16, okay, instead of the decimals? Focus on that, on those when you do those. These 2 up here, I really want you to rock and roll. Here's your steps again, sitting right by you. That should be in your notes that you can reference to. Go ahead and do that. Okay, we're back. I'm going to quickly go through these with you, all right? So in this one right here, we look at numbers first, and we have 5x to the 5th plus 10x squared minus 8x. 5 goes into here, 5 goes into here. Does 5 go into there? It does not. So you numerically did not have a common factor, but you have x to the 5th, x squared, and x. And so your common factor does indeed equal x. That's the lowest degree of the common variable. You take 5x to the 5th, you put it over x. You take 10x squared, you put it over x. You take minus 8x, you put it over x. You simplify. And so x to the 5th over x leaves you just with 5x to the 4th. X squared over x just leaves you with x, and you have plus 10x. And x's cancel, and you have minus 8. This goes into parentheses. The common factor comes along for the ride, and that was your final answer, okay? Say woo if you got it right. Give me a woo, Nicole.
Woo.
Woo. Oh, Nicole, that sounded lame. 1, 2, 3. Woo. There we go. That girl. That's my cheerleader. Okay, that's good. That's good. Okay. All right, let's do this one, okay? Look at this. Numerically, 14, negative 21, positive 7. What's the numerical common factor? Is there one? Yes, 7 goes into all of those, okay? So my common factor here equals 7, okay? We have a p to the 6th, p to the 4th, and a p to the 2nd. Is all this coming up on the camera, Nicole? We're not writing off the edge of the board here, are we?
No, you're good.
Okay, good. And so we have the p to the 6th, p to the 4th, p to the 2nd. The lowest degree of the common variable p is p to the 2nd, q to the 4th, q to the 3rd, and q to the 2nd. The lowest degree of the q's is also q to the 2nd. So we have 7p to the 2nd, q to the 2nd. So we are going to rewrite this. We're going to have 14, p to the 6th, q to the 4th, over the common factor, 7, p squared, q squared, minus 21, p to the 4th, q to the 3rd, over 7, p squared, q squared, and then plus 7, p to the 2nd, q to the 2nd, over 7, p to the 2nd, q to the 2nd. Okay? We got that. So all the terms, put this under each one. Simplify this bad boy, or this good girl, or whatever the fetch it is. We've talked about bad boy before. Whoop, okay? Check it out. Numbers to numbers, 14 divided by 7. Nicole, what is that? 2. Thank you. P to the 6th over p to the 2nd is p to the 4th. Q to the 4th over q to the 2nd is q to the 2nd. 21 divided by 7 is 3. So we have minus 3. P to the 4th over p to the 2nd is p to the 2nd. Hey, what's p to the 2nd? PP. That's right. Q to the 3rd over q to the 2nd is q. Okay, 7 over 7 is 1. P to the 2nd over p to the 2nd is 1. Q to the 2nd over q to the 2nd is 1. What does that leave you? 1. Okay?
1.
And so we put all of this in a parentheses. The common factor comes down for the ride. 7p squared, q squared, and that is our answer. Say woo if you got it right. 1, 2, 3. Woo! Nicole!
Woo!
Oh, man. Okay, that's good. All right, guys. Real fast, I'm just going to help you with these super quick because I want to teach you the next method. I don't want to spend a whole lot of time on this. But here's the deal. It's numerically, what you have here is a denominator of 9. And so you have a common factor of 1/9. And you have x to the 7th, x to the 5th, x to the 3rd, and x, so you have 1/9 x. If you think about this, and you divided this by 1/9 x, and divided this by 1/9 x, and divided this by 1/9 x, and divided this by 1/9 x, you're ultimately going to be pulling out the denominator of 9, and all that's going to be left is the numerator, and then you can simplify the x's. I want you to think about this for just a minute. Just take this right here. I don't want this to confuse you. If you took 5/9 and you divided it by 1/9, okay? You, in essence, would be taking 5/9, you change division to multiplication, and you flip the second fraction, and these cancel, and like I said, what's left is just the 5. When you divide out a 1/9, you remove all the common denominator of 9s. So I'm not going to do this long division thing here for all of these. I'm simply going to tell you that 1/9 x is the common factor, and what's simplified is going to drop down in here. These 9s right here will cancel and leave you with 5. X to the 7th over x is x to the 6th. These 9ths will cancel because 9's on top and 9's on bottom makes 1, right? And you have plus 2x to the 4th because x to the 5th over x to the 1st makes x to the 4th. Again, this will cancel with that 9, and so we'll have minus 4 x to the 2nd because we have x to the 1st, and then 1/9 over 1/9, again, these cancel, but you're left with minus 1, and then these x's cancel, so you're just left with minus 1, and that's your answer there, okay? So you're going to see a fraction problem like that, and that'll be a good start for you to get that done. If you need more help with that, because of interest of time, we don't have lots of time to go through lots of these, you can get online with one of your online tutors. 2.4x to the 4th plus 0.8x to the 3rd plus 1.6x squared. What I want you to understand is, look at this. Let's say I got rid of all of these, okay, and that would mean getting rid of the 0. Then you would tell me that you had a common factor of what number? 8. That's right, 8. And so let's go ahead and put those back there. And so if we think about that, then our common factor isn't 8, it's 0.8 because we have a decimal, one decimal place that's also common amongst all of those, okay? And then, okay, x to the 4th, x to the 3rd, x squared. And so you put this over 0.8x squared, 0.8x squared, 0.8x squared. How did I get x squared? Because in essence, I look at the lowest degree of the common variable, okay? You divide those on a calculator. Guess what? It's going to be just like 24 divided by 8. It's going to give you 3x to the 2nd. This is going to give you 1x. So we're going to have, I'm sorry. Oh, wow. That was cute. Let's get the eraser real quick here. Okay? And we're going to have, plus 1x, which is just plus x, because x to the 3rd over x squared makes x. These cancel out. And then 1.6 divided by 0.8 will be plus 2, and the x squareds cancel each other out. I want to show you one last thing before we cut to our next factoring method, factoring by grouping, okay? All right, I want to erase some of this real quick. All right. Nice thing is, if you're sitting there going, no, don't erase it, you can always go back because you have videos. How nice for you, okay? I want to show you something interesting here right now. Again, I want you to get this because this is the beauty of factoring. Everybody, if I asked you to multiply this out, now are we being asked to multiply this? No. I'm just saying, if I asked you to, what is x times 5x to the 4th? That's right, 5x to the 5th. And what's x times 10x? Yeah, that's right, plus 10x squared. And what's x times negative 8? That's right, negative 8x. Look at this. Look at this in blue. They are the same. That's right. Math is the manipulation of numbers to look different but remain the same. Factoring is just the opposite of multiplication, so if you multiply it out, you get back to the original problem. Same thing here, if we did this, 7 times 2 would be 14. P squared times p to the 4th would be p to the 6th. Q squared times q squared would be q to the 4th. And this one, 7 times negative 3, negative 21. P squared times p squared would be p to the 4th. Q squared times q would be q to the 3rd. And 7p squared q squared times 1 would be 7p squared q squared. Look at this. Look at that up there. They are the same. All right, let's pause for a minute. We're going to take notes on our next method. Welcome back. Okay, so today's assignment, we're covering 2 methods of factoring. Go back in your notes and look at all of our chart of factoring. We just finished pulling out the common factor method. We're now doing method 2, factoring by grouping. I want you right now to pause your video and take notes on this process. Write it all down. Go. Okay, so you're back. You've taken notes on this. Okay, I got to tell you, things like this are virtually meaningless if you don't see how it's done. So these 2 things, doing the example and having the process hand in hand, you need them both. this right here looks like a bunch of gibberish if we don't do a problem. So the first thing I need you to understand, everybody, is you need to always, in the back of your mind, you need to have your cancer doctor chart next to you at all times. So we said our first method is pulling out the common factor, and every polynomial has the potential to have a common factor in it. Factoring by grouping works when we have 4 terms, okay? So these are the terms that these type of methods are possible on. Pulling out the common factor, all polynomials have the potential. Okay, again, they won't all have a common factor, but we must look. And then we have the other methods here. We're going to forget about these for right now because we haven't learned them yet. So the first thing we need to do in every problem, did you hear that? Some problems?
No.
Every problem. Thank you, Nicole. Okay, no. Okay, every problem we got to check to see if we have a common factor. Look up here. 18. That is divisible by what? Things that you can see maybe over here. It's divisible by 2. Is that divisible by 2? Nope. Okay, so we'll start over. It's divisible by 3 because 1 plus 8 makes 9. Is that divisible by 3? Yes. 2 and 1 make 3. Is this divisible by 3? Yes. Is this divisible by 3? No. 3 and 5 make 8. Okay, so we do not have a numerical common factor, and it doesn't matter that these 3 were divisible by 3. They all have to be divisible by 3. We talked about this, okay? It has to be common amongst all the terms. We have an x, we have an x, we have an x, we have an x here. No, that last term in there kind of screwed us over in terms of getting a common factor. We have no common factor, but we had to check. We always do. Remember, we're cancer doctors. We want to check our patients thoroughly, and every patient has the potential to have a common factor. But it does have 4 terms. It does have 4 terms. Look at that. And because it has 4 terms, we need to now examine if we can factor by grouping. So we're going to reorganize these 4 terms into a binomial plus a binomial. That's step number 1. Very simple step. We're literally going to take this and say 18x to the third minus 21x squared. Put a parentheses around that. Always write plus here. Okay? I'm going to put this right here. Always write plus there. And bring the sign before the term with it, okay? And we're going to say 30x minus 35, okay? Now, some of you could say, well, why didn't you just put a parentheses around this and a parentheses around that? And you're right, it would have worked, but it doesn't always work. So always write this second step. I'll show you later why it doesn't always work. Now, we're going to use our pulling out the common factor skills that we just developed, and we're going to pull out the common factor from each binomial. So we just created 2 binomials here. So we're going to do this problem. We're going to look at these 2 terms, and I ask you, what is the common factor amongst these 2 binomials? Okay? So we're going to first say, all right, let's see, 18 and 21. What goes into both those? That's right, 3. Good job. Okay, so we have a common factor of 3. And x to the third and x squared, lowest degree common variable is x squared. And then if you remember, we put that underneath each term. Okay, the common factor goes outside of the parentheses, so what's simplified goes in here. It's nice, we can drop this right in. 18 divided by 3 is 6. X to the third over x squared is x. The minus comes down. 21 divided by 3 is 7. And x squared cancel each other out. Okay, now that's just taking care of this. What's the common factor in this one, right? So we do each one of these binomials individually. So looking at 30 and 35, they both are divisible by 5, okay? And so we drop down this plus that comes along for the ride. This is going to be 5. We're going to put this over 5 and this over 5, and we get 6x minus 7. Now look at that. These 2 parentheses are the same. Yep. And it says right here, your parentheses are now the same. Phenomenal, okay? If they are not the same, this method won't work. And this patient is free of any cancer by this method, okay? Or factoring in this method, if we're pretending we're cancer doctors. Okay? So your parentheses are now the same. Okay. Let's see. Nicole, just be careful. You're not jiggling the camera there. And I just want to make sure nothing's shaking. All right, you guys be like, whoa, we had an earthquake. No, that was Utah. If you're down in Utah, we're not having an earthquake here. Nicole is just texting somebody while she's running the camera, so I just want to make sure. Hey, is this close enough? Woo! Is that freaking you out? Okay, good. All right, check it out. So now we have a common parentheses. Please watch this. This is the brain hurdle. This is hard for your brain to get over. Okay, I'm going to show you this. I want you to learn this. We got to nail this down. You're going to pull this out like a common parentheses. A common factor. So the common factor is 6x minus 7. Okay? Now think about this. If you placed all of this over 6x minus 7, and all of this over 6x minus 7, just like you place a common factor under each of these could cancel, and these could cancel, and what's left over goes outside of the common factor. What's left over is 3x squared. Ooh, that's a nasty squared. Let's erase that. Do that again. Okay? All right? So 3x squared plus 5. And that's what it says right here. Look up here. Your parentheses are now the same. Pull out the common parentheses. That's what we did. We pulled out the common parentheses of 6x minus 7. So we divided each of these two different sets by that. Got rid of them. What is left over drops in, just like we do with a common factor. And then the answer format is always going to be a binomial times a binomial. And the common parentheses is in this binomial. And what's left over goes in this one. And that's your final answer. Now let's play a game. Okay? Let's play a game called Check Your Fetch and Answer. Woo! Okay? Can you say that with me? Check your fetch and answer. 1, 2, 3.
Check your fetch and answer.
Woo! There we go. 6x times 3x is 18x to the third. 6x times 5 is plus 30x. Negative 7 times 3x squared is negative 21x squared. Negative 7 times 5 is negative 35. And if you rearrange these two terms, you have 18x to the third minus 21x squared, putting it in descending order, plus 30x minus 35. And this are the same. Okay? Now one thing I want to share with you, everybody, I want you to get this, because what if your answer in the back of the book says 3x squared plus 5 times 6x minus 7? This is going to happen. Okay? What's 2 times 3, everybody? 6. What's 3 times 2? 6. They are the same, right? You can rearrange multiplication and it remains the same. These two things are being multiplied. If you rearrange them, it's going to be the same. 3x squared times 6x is 18x to the third. 3x squared times negative 7 is negative 21x squared. 5 times 6x is 30x, and 5 times negative 7 is negative 35. So whether you write it this way or this way, the answer is the same. Please don't forget that, because you're going to see in your homework, sometimes they write it this way, sometimes they write it that way. On the test, it could be written either way, and as long as you know those are the same, you're in good hands, okay? Okay, I want you to pause for just a second and just kind of think about this and write anything down. If you don't need to pause, we'll move on. Okay. I want to show you something kind of fascinating here, and I need you to bear with me. I'm going to, just for a second here, I want to rewrite this problem right here at this point, and I want to redo this with you and show you something interesting here. Okay, I'm going to erase this, even though we know that's the same. We're just going to get rid of that because we don't need to look at that. Okay, at this point here where I have 3x squared times 6x minus 7. Plus 5 times 6x minus 7. I told you this is the brain hurdle when we take this common parentheses out and put it in the corner of the problem here, and then what's left over goes in the other binomial. If you want to just memorize that and always do it, you'll always get the problem right. But I want to show you something. What if I said, let 6x minus 7 equal big A? Now please listen, this is just for purposes of learning. This has nothing, you're not going to do this on your actual homework, okay? But I want you to watch this. You say, well, Brother Rich, why are you letting that equal big A? Because I'm the math teacher and I can do whatever the fetch I want, all right? So I'm going to let that equal big A, okay? So if we do that, do you agree with me then that I would have in essence 3x squared times big A, okay, plus 5 times big A? Because where there's a 6x minus 7, I'm going to replace it with the big A. You get that? So how many terms are in this polynomial right now, right? That's one term plus another term. Terms are separated by plus or minus signs. If I ask you to pull out the common factor, factor out the common factor from this binomial, what's the common factor? That's right, it's big A. And so we take big A, and we put this over big A, and we put this over big A. They cancel, the common factor goes here, and what's left over, after it's simplified, 3x squared plus 5 goes in here. But what was big A to begin with, right? It was 6x minus 7. So this is just another way to show you why it's possible. So look, there it is, 6x minus 7, 3x squared plus 5, 6x minus 7, 3x squared plus 5. This is just another way to show you that this is possible. Okay, Nicole, let's pause this for just a second. Okay. All right, thank you, Nicole. So check it out. We have another polynomial up here, and I want you to do this problem right now. I want you to remember your process. Okay, your overall process. First check for a common factor, and then factor by grouping. Okay, I'm going to pause for just a second. All right, we're back. We're going to do this one with you. Okay, so real quick, check for a common factor. Divisible by 5, divisible by 5. Is that divisible by 5? It is not. But that doesn't matter because they all have to be divisible by 5. Divisible by 2, 2, 2, but that's not. Okay, so no numerical common factor, x, but no x, but you had to check. Because every polynomial has the potential to have a common factor, so you must always check. Don't forget that. Don't get out of that habit. It's really important. Okay, so here we go. We're going to break this up. We have 4 terms. So now factoring by grouping becomes our next viable option. And so we say this is 10, x to the third minus 25x squared. And what do we put here? Always plus, that's right. And the other terms with their signs, 4x minus 10, go there. If that had been negative or a minus, the minus would go inside here and a plus would go there. Don't forget that. It's going to come back to haunt you if you don't. We're going to do some examples where you're going to be required to do that. So what's our common factor in these two here, the common fetcher? Yep, it is 5. X squared. Okay, so we put this over 5x squared, we put this over 5x squared. Both those were divisible by 5. Lowest degree of the common variable is x squared. We simplify it, we get 2x. X to the third over x squared makes x. 10 divided by 5 makes 2. 25 divided by 5 is 5. X squared over x squared is gone. What's our common factor here? What are they both divisible by? 2. So the plus comes along for the ride. We have 2 here. We divide this by 2. We divide this by 2. We get 2x minus 5. Woo! Our parentheses are the same. Look at that. So cool how that works out. Okay, we're going to bring those over here. We get 2x minus 5. What's left over? 5x squared plus 2. Do we put a plus in between here? Fetch no. Don't ever do that. This is always a binomial times a binomial. Because when we multiply this out, we got to get the original problem. Do you want to play that game? Should we do it real quick? Okay, let's do it super fast, okay? We don't have a whole lot of time. 2 times 5 is 10. X times x squared is x to the third. 2x times 2 is plus 4x. Negative 5 times 5x squared is negative 25x squared. Negative 5 times 2 is negative 10. So we put it in order. 10x to the third minus 25x squared plus 4x minus 10. And that are the same. Woohoo. Let's go ahead and hit a pause button here, Nicole. Okay, I got 2 problems here that I'd like you guys to tackle on your own using this process that we've learned. Let's see what you can muster up. Okay, so when I say stop, let's stop the video. Go ahead, stop. Okay, real quick, there are the answers to those 2 problems. See if you did them right. Let's go ahead and do them together real quick. All right, if you need to pause at any time, go for it. Here we go. So the first thing we need to do in this problem is, with all problems, is check for a common factor. If you miss that, like I said, it's going to come back to bite you here and there. Every problem has that potential. All these are divisible by 2 because they're all even numbers. So we pull out a 2, we put this over 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 2. We pull out the common factor, we get x to the third plus 8x squared plus 6x plus 48 if you need to do that on a calculator to help you out. We now have 4 terms. Now I want to show you a little be thorough, be organized step that I like to use. I like to take an arrow and bring that down into my answer, okay? And leave that 2 there. I like to just draw that 2 down there and make sure that it's part of my answer so don't forget about it. I factored it out, it's part of the answer. We're now going to take these 4 terms and reorganize them into x to the third plus 8x squared. We always put plus in the middle. We have 6x plus 48. We're going to pull out the common factor from each one. The common factor here is x squared. We're going to put this over x squared and put this over x squared. And we get x plus 8 when we simplify that. Okay? X third over x squared is x. X squared over x squared cancels. We're just left with 8. My common factor here, that's right, it's 6. We're going to put this over 6. We're going to put this over 6. And we get x plus 8. Look at that, the parentheses are the same. The common parentheses, x plus 8 goes here. What's left over is x squared plus 6, and that drops down. If you remember, we're in essence dividing this by x plus 8, and in essence dividing this by x plus 8 because it's the common factor. They cancel. What's left over is just x squared plus 6. The common parentheses is the common factor at that point. It's the x plus 8. That's why it's called factoring by grouping, because you're finding a common group and pulling it out like a common factor, okay? This one right here, okay, this is an interesting problem. It posed a little difficulty. There's something here. It says, your parentheses are now the same. Pull out the common parentheses like a common factor. And it says here, don't give up easy. If the parentheses are not the same, this method doesn't work. First we look for a common factor. You found that there isn't one. 2 goes into here and here, but not here. Okay, x, but no x there. So we're going to break this up. 2x to the third plus 12x squared in parentheses plus, always a plus, negative 5x minus 30. Okay, if you didn't catch that, it comes back to haunt you a little bit. Pulling out the common factor here, what I'm saying is always put a plus there. The sign before the term goes with it. If you get lazy, folks, and you just put a parentheses here, you're in essence saying that's negative 5x, but you're in essence saying that becomes positive 30. And you just manipulated math to look different and be different, and you would get the problem wrong. So that's why you don't want to get lazy and just put parentheses around each binomial. You've got to have the sign before the term always going with it. Common factor here is 2 goes into both of them. Lowest degree of the common variable, x squared. We'll put this over 2x squared. Think about that. X to the third, x squared, lowest degree common variable, 2x squared. And so this cancels. X to the third over x squared is x. 12 divided by 2 is 6. X squared over x squared is gone. We need this parentheses to be x plus 6. So you look at it and you say, hey, I have a common factor of 5. So if you put this over 5 and you put this over 5, you end up with plus. And in here you have negative x minus 6. And those parentheses are not the same. And I'm telling you, we don't give up easily. They're so close to being the same. What if you had told me this was a negative 5? So earlier I told you don't need to worry about the negatives when it comes to common factors. But in something like this here, we can factor out a negative. Look at what happens if we factor out a negative, okay? So you know these two terms were positive. So you know these two terms need to be positive. So factor out that negative 5, and then what happens here is this becomes minus 5. That's your common factor there. And these cancel, you're left with x, and then negative and negative make it positive 6, and now those parentheses are the same. Look at that. We pull that common parentheses out, x plus 6, and what's left over is 2x squared minus 5. Now, are these two answers the same? They absolutely positively are, because they could come in either order. Let's go ahead and hit pause, Nicole. Okay, guys, in interest of time, I would love to give you some more practice problems, but I want to quickly show you a couple things that are going to come up. So part A of your homework is method 1. Part B of your homework is method 2. The first thing I want to show you on the far right here is that the first few problems, they set up like this. The student's like, whoa, what's going on here? Okay, what they're doing is they've done step 1 and 2 for you, and they're in essence telling you, start here at step 3. So you're going to pull out the common parentheses of x plus 3, and what's left over is x squared plus 2, and you're done, okay? So they're just trying to get you used to the concept of, hey, we divide this by x plus 3, we divide this by x plus 3. And you know what? If you want to, you could put x plus 3 over here, and you could always put the other stuff there. Okay, so it's kind of interesting. You could put the common parentheses on the right and put the leftovers here. So we could switch this, and that will always give you the same answer as the one in the back of the book. So here we go. We'll call this, look at this, we're gonna change this up. And we're going to say, you know what, fetchers? We'll go ahead and we'll put the common parentheses here, and we'll put the leftovers here, okay? Now this problem right here, I'm going to do this one with you real quick. You check for a common factor, you don't have one, okay? You break this up into a binomial plus a binomial. Watch this. I'm going to go like this and like this, but I got to put a plus in between them. So I'm ultimately going to have 7x to the third minus 14x squared in parentheses plus negative x plus 2. What's my common common factor here? That's right, it's 7x squared. I put this over 7x squared, I put this over 7x squared, and I get x minus 2. You're like, why are you going so fast, Brother Rich? Because we don't want to take too much time teaching you stuff. We want to keep it within an hour limit. Check this out, negative x plus 2. Okay, man, that sure looks similar to this. I don't want to give up easy. What if I factor out a negative 1? So I put this over negative 1 and I put this over negative 1. Negative over negative makes a positive. X over 1 makes just x. Positive over negative makes a negative 2. Look at that, fetchers of America. Those parentheses are now the same. Okay, and then we have x minus 2. But we said, you know what? We're going to put that one over here. X minus 2 is my common parentheses. What's left over is 7x squared minus 1. You multiply that out, you'll get the original problem. You guys rock. Good luck. Like I said, this is a challenging chapter. This is hard work. Put your work into it. You have 26 problems you have to do, and 1 through 51 on. You guys have a good one. I'll see you next section.